Data parallelism in distributed systems with OS and SageMaker. Definition: the technique of replicating the entire model across multiple nodes in a distributed system and distributing training data across these nodes. Leveraging AWS, Amazon Web Services, and SageMaker for efficient model training and scalability. Key components: AWS services, SageMaker, fully managed service for building, training, and deploying machine learning models at scale, supporting distributed training with data parallelism. ECS/EKS, Elastic Container Service (ECS) or Elastic Kubernetes Service (EKS) for managing and orchestrating distributed computing tasks across nodes. Lambda, serverless compute service for executing code in response to events, suitable for lightweight tasks in distributed environments. S3, object storage service for storing training data, model checkpoints, and other resources. API Gateway, managed service for creating, publishing, maintaining, and securing APIs, facilitating communication between distributed components. Data parallelism techniques, model replication, replicating the entire model across distributed nodes to process data in parallel. Batch processing, dividing training data into batches and distributing these batches across nodes for simultaneous processing. Parameter server architecture, using dedicated parameter servers to distribute model parameters and aggregate updates from distributed nodes. Asynchronous training, implementing asynchronous training to allow nodes to update model parameters independently and asynchronously. Benefits: scalability. AWS ECS/EKS enables seamless scaling of distributed computations across nodes, accommodating varying data loads. Efficiency, improves training efficiency and reduces training time through parallel processing of training data across distributed nodes. Flexibility, supports diverse model architectures and configurations, adapting to different distributed computing requirements. Resource efficiency, optimizes resource usage and reduces overhead in distributed systems with parallel data processing techniques. Cost effectiveness, reduces operational costs by utilizing AWS managed services for distributed computing and data parallelism. Tools and technologies. AWS SageMaker SDK, Python SDK for interacting programmatically with SageMaker services, facilitating integration and automation in distributed model training. AWS ECS/EKS, orchestration services for managing distributed computing tasks and containerized environments in AWS. AWS CLI, command line interface tool for efficient management and configuration of AWS resources and services in distributed setups. CloudFormation, infrastructure as code IAC tool for provisioning and managing AWS resources, ensuring consistency in distributed deployments. TensorFlow PTorch, popular frameworks for implementing data parallelism techniques in distributed training and computation. Challenges: complex infrastructure setup, designing and configuring ECS/EKS clusters and SageMaker endpoints for optimal performance and scalability in distributed data parallelism. Data synchronization and communication, managing data synchronization and communication overhead between distributed nodes in parallel data processing. Debugging and optimization, establishing robust monitoring and debugging mechanisms for performance optimization and issue resolution in distributed model training. Security and compliance, implementing stringent security measures and ensuring regulatory compliance in distributed computing environments. Skill set requirements, requiring expertise in distributed systems, data parallelism, and AWS services for effective implementation and management.